பார்க்கறதுக்கு எனக்கு இதான் கன்வீனியன்ட்டா இருக்கும்.
தண்ணி இருக்குங்களா? வாட்டர்
எதுவுமே இது நகர மாட்டேங்குது. திவ்யா
நடுவுல உங்களுக்கு தண்ணி குடிக்கணும்னா
சரிமா
ஒரு 5 மினிட்ஸ்
எக்ஸ்கியூஸ் மீ
சொல்லிட்டு வீடியோ எங்க இருக்கு பாருங்க சார். வீடியோ இப்போ இந்த வீடியோ ஆஃப் பண்ணீங்கன்னா நீங்க தெரிய மாட்டீங்க. உங்க பேர் மட்டும் வரும். செக் பண்ணிக்கோங்க. ஓகே. இல்ல நீங்க எங்க கிட்ட ஏதாவது பேசணும் அப்படின்னா இப்படி வந்து சார் ரைட் கிளிக் பண்ணி
அது ஆரோ யூஸ் பண்ண முடியுமா? டவுன் ஆரோ தான் வருது. டவுன் ஆப் தான் வருது. சரி மேடம். தேங்க்யூ மேம். லேசா பார்த்துட்டு பாருங்க. பண்ணிடலாம் மேடம், பண்ணிடலாம்.
வந்துட்டாங்க மேம். 95 people 97 சார்.
அன்மியூட்ல தானே இருக்கு.
இப்போ உங்களை
மியூட்ல தானே இருக்கு. சரி
இல்ல எடுத்துட்டோம் சார், வெளில வந்துட்டோம்.
சார் திவ்யா மேம்
கோவிந்தன் சார்
மியூட் பண்ணுங்க.
மியூட் பண்ணிட்டீங்களா?
ஆமா. சொல்லுங்க. மியூட் பண்ணுங்க.
மியூட் பண்ணிட்டீங்களா?
கோவிந்தன் சார். சார் ஸ்டார்ட் பண்ணிடுவா?
ஸ்டார்ட் பண்ணலாமா?
ஸ்கிரீன்ஷாட் பக்காவா எடுத்து வச்சிருக்கீங்க கையோட. ஜூம்ல
சரி நான்
கோவிந்தன் சார்.
சொல்லுங்க மேம்.
சார் ஸ்டார்ட் பண்ணிடுவா?
ஸ்டார்ட் பண்ணிடலாம் மேம். ஸ்டார்ட் பண்ணிடலாம் மேம். நீங்க உங்களுக்கு நெட் கரெக்ட்டா உட்கார்ந்துக்கோங்க. நெட் சரியா உங்களுக்கு இல்ல.
எங்க இருக்கீங்க மேம்? எங்க இருக்கீங்க?
நான் இங்க டிபார்ட்மென்ட் வந்திருக்கேன்.
ஏன்?
ஒரு வர்க்குக்காக வந்தேன். சொல்லு. நான் ஸ்டார்ட் பண்ணிடவா?
நீங்க வச்சிருக்கீங்களா? எங்க நம்ம
வச்சிருக்கேன். உன்னோடது அங்க சர்வர் ரூம்ல இருக்கு, எடுத்துக்கோ. அங்க பாரு, சர்வர் கேபின்ல இருக்கு பாரு. ஹலோ திவ்யா. திவ்யா நீ மியூட்ல இருக்க.
மேம்
நான் ஸ்டார்ட் பண்ணிடுறேன். அட்மிட் பண்ணுங்க.
எனக்கு வீடியோ வருதா? வரலையே.
உன்னோட வீடியோ வருது.
ஐயோ,
உன்னோட வீடியோ.
ஓகே சார்.
ஸ்டார்ட் பண்ணிடுவா?
மேம் வெயிட் பண்ணுங்க. Sir, is it audible?
Yes, okay.
Yes, ma'am.
We are start
Shall
பண்ணி.
we start?
Good morning to all. Once again, and I welcome you all to the 1 week HTTP on computer networks. Now, I welcome Mrs. B. Divya, Assistant Professor CSE, to give introduction about today's resource person.
Good morning to all. Welcoming the resource person. It gives me a great pleasure to introduce the resource person of today's session, day 3, Mr. M. Anandakumar, Assistant Professor, Department of Computer Science and Engineering, Aras Engineering College, Kumbakonam. He completed MBA in Bharatiyar University, completed BE in Satyabama University, completed ME in Satyabama University, completed BE in ARJ College of Engineering and Technology. Overall, 10 years of experience in teaching. His certifications are Certified Cisco Course Instructor for CCNA course, completed Cloud Course Certification from EMC Square. His area of interest are networks, cloud computing, big data analytics. He organized more than 10 programs. He published almost 10 papers in various national and international conference and journals. SAR published 2 books, namely Computer Networks and Communication Networks, based on the syllabus of Anna University for both Regulation 2013 and Regulation 2017. Also, he published computer programming books for Anna University syllabus. Currently, he is acting as an NSS program officer. His awards are, he received Best NSS Program Officer Award, also Best NSS Unit Award 2 times, and Best Social Worker Award. Acted as a resource person for 11 programs. Under this banner, he organized more than 250 programs. Now, I hand over the session to the sir. Welcome, sir.
Thank you, Divya ma'am, for your great and wonderful introduction. I will explain IP addresses and subnetting. First of all, we will concentrate IP addresses. So IP address is covered by voice reference model network layer. This is a connectionless service, no pre-establishment. Why we call as connectionless service? In the sense, this is a without the feedback, we can transfer from source to destination. Packet can transfer from source to destination without feedback, so that we call as a connectionless service. This is a much more speed for the packet transferring. No pre-establishment here, and best effort service. Without the feedback, always we can increase our speed. Next, end-to-end connection. The end-to-end connection focuses from source to destination and destination to source. We can consistently transfer our data. Next, media independent, also supported by the IP. The IP can classify in the 2 types. One is IP version 4 and another one is IP version 6. First, we will discuss about IP version 4. In the IP version 4, 2 types of address is there. One is classful address, another one is classless address. The classful address is classified in the 4 categories. One is class A. The class A, all addresses in the classful contains 2 categories. One is network ID, another one is host ID. The network ID identify the networks. The host ID identify the destination system. So both classification is there. The class A focuses from 1 to 27. That is only one net ID and 3 host ID. The one net ID, the IPv4 contains 32-bit address. So first 8-bit covered by net ID. The remaining 24 bits covered by host ID. 1 to 27 maximum support by class A category. Next, classification B. This is 8 plus 8, 16-bit network address and 16-bit covered host ID. So totally from 128 to 191 ID we can create from classification B category. Next, classification C. This is net ID maximum 24-bit net ID covered by classification C category and only host ID 8-bit. So from 192 to 223 maximum covered by classification C type. Classification D is a group address. This is only using the multicasting address. This is starts from 224 to 239. Classification E reserved for research purpose. This is starts from 242 to 55. So next, IPv4. So IPv4 is a deliver packet from source to destination, and IP packet is sent to destination without prior establishment. It was not designed to track and manage the flow of packets. This is covered by IPv4. The header format of IPv4 is first version. The version is defined IPv4, that is version 4. The next IP is there, another one is IPv6. Here IPv4 is a version. Next, header length. The header length is focused the length of the datagram. So exact how many bits are covered by the datagram. This is defined the header length. Next, differentiated the service DHCP and ECN. This is focused priority. That is how many number of routers are present in the network and how to define the traffic and how to define the buffer and buffer overriding. This all the things covered by this area. Next, total length. This is a total length 32 bytes covered. Sorry, 16 bytes covered by the length of the datagram. Next, identification. The identification is a data bit identification. Next, flag. Flag is 3 types. One is no flag is set. Another one is flag is idle, and next is flag is more. This is connection with the fragmentation. So if we are sending data from source to destination, so our volume may be a maximum size. So we cannot send raw data. Ultimately, we partition the information, that is our original information, so partitioned many more packets. So that is a fragmentation from source to destination. In the source side, we fragment the information, and the destination side and reassemble the packets. So this flag is focused related with the fragment offset. So the fragment offset is related to reassembling the process. So in the destination end, receive all the packets and assemble the original information. So time to live. Next one is a time to live. The time to live is a focused only on the router. So in our network, how many number of hops are there? So if the packet crossed one router, the hop number 1 will be decreased. Finally, the hop limit is 0. So our packet is successfully delivered to the destination. So time to live focused on the router. So protocol. So IPv4 directly within a network, we can easily broadcasting. We easily transfer the information from source to destination beyond the network. So ultimately, this cannot be supported by the IPv4. Ultimately, we can use in the network layer additional protocol, IPs, ICMP, UDP, and TCP. This is supported by the protocol portion. Next, header checksum. Suppose any error rising during the transformation, so the checksum will be identified. So next, source IP addresses. This is a 32-bit. This is supports in the source system. The destination IP focused in the destination system. So IPv4 totally 32-bit length IP address. So beyond the IPv4, somewhat a special address is there. That is loopback address. The loopback address only within the network we can transfer the information. So that what kind of IP we should configure. So the loopback address is very useful to inside the network. That is intranet is very convenient to this. 127.0.10.02 127.255.255.255 up to 255, this will be support. Next, link local address. So link local address, if suppose we are erecting the LAN, so beyond the LAN when we are going to transfer our information, so the link local address will be very helpful. This is starts from 169.254.0.12, 169.254.255.255. Up to this, the link local address will be supports to you. Next, test network address. Suppose when you are going to test before the erection, when you are using the packet tracer or some other simulator, we can use these kind of test addresses. Starts from 192 to 255. Next, experimental address 242 255. This is a experimental address. This is a research purpose. Ultimately, we are using. What all the limitations are there in the IPv4? IP address depletion is very peak. Internet routing table is very peak. Lack of end-to-end connectivity is there. These are all the constraints to IPv4. So ultimately, we migrate from IPv4 to IPv6. And before that, we will try to configure IP address in the packet tracer environment and configure DHCP. The DHCP, we avoiding manual configuration so that we configure DHCP. Without a manual intervention, we can configure DHCP. So first we will configure IP address in the packet tracer 7 environment. So this is an open source. You can download from the internet and install your system. Just you log on. If you are a paid user, you can log in over the user login. Otherwise, guest login will support total. All the features are there in the guest login. You log in through guest user. So now we will try to create one small LAN and assign IP address to all the machines. So first, this is a packet tracer 7 environment. So these are all the networking tools. So first, you will take one switch. So click the switch and put on your environment. Simply, the switch will be appear on the screen. And next, we will configure according to your wish. You can configure your how many number of machines you want to desire to connect. You can configure. So I'm taking 3 machines with 1 router. So next, this is a physical equipments. And next, you want to establish over the cables. So directly you can choose this. You can directly interconnect from system to switch. So totally how many number of machines you want to desire to connect this, we will do like this. right? So 3 machines you have connected with one switch, and directly you open your PC, go to desktop, IP configuration. So you want to design, configure a static type of IP. You choose static, otherwise go to DHCP. First we will try to static. So this is your IP 192.168.1.2. This is your IP. Subnet mask, if you try to put a tab key on your keyboard, the subnet mask ultimately take by the packet tracer. Just close it. Same like this, we will try to do all the node. So we created one LAN. This is a very, we take only 3 machines. If you are like, you can increase your number of machines, right? We created one LAN and we assigned IP addresses, particularly IPv4. So we verify our connectivity, if it is right or wrong. Just click your machine, go to command prompt. So one familiar command is there, ping, P-I-N-G, type ping and space. So which machines you want to check. So ultimately you put your, according to that you put address. So we got reply from 192.168.1.3 byte 32 time 1 millisecond, time to live is 128 TTL. So this connection is 100% is perfect. So with the help of ping command, you can verify your connectivity. So this is a small LAN. If you're interested, you can erect another one LAN. You can directly interconnect both LAN. So we will try to erect another one LAN. We'll take one switch and you have decided system, you can next. So here one important thing we must remember. So this is one LAN, this is another one LAN. This physical connectivity is excellently successfully done. At the moment, if we interconnect with the 2 LANs over the switch, so one important thing we should remember, this is a switch, this also switch. When you're going to interconnect with this, so this cable is a straight through cable. So according to color combination, we call this kind of a link is PCP TPC3 to switch. This interface is a straight through cable. This is a switch, this also switch. So if we interconnect with 2 switch, ultimately we should use crossover cable, otherwise our connection will be fail. So this is a very important thing you should remember. So physical connectivity almost over. Next you should assign IP. So we assigned IP to the 3 machines. and we interconnect two switches. This is LAN 1, you consider as this is LAN 1, this is LAN 2. So with the crossover cable, we interconnect both the local area networks. Just verify your connection. Go to command prompt. This is a LAN 1 IP. LAN 1 IP is successfully connected. So that machine is replied. So next, check LAN 2 IP. This is also replied. So ultimately, both local area networks are successfully connected. So this is a small experiment for your fan perusal. So next we will concentrate dynamic host configuration protocol. So this manual IP we can avoid. So directly we can connect DHCP. The DHCP ultimately, if you configure, no need to put IP to the particular machine in the manual. We avoid manual intervention. So ultimately, we will try to create another one network. Take one switch, and as you wish, you will take systems. So 4 machines I have connected. Okay, if you just enable DHCP, ultimately you will get IP. So we get dynamic host configuration protocol. If you configure the manual intervention, ultimately avoid. Automatically the IP will be generated by the DNS. So we will try to create. So enable DHCP, that's all. Very, very simple task. Automatically this will be checked. Okay, 4 machines have connected. Next, verify your system. So 169. Two 5442. So this is connected. So this is a successfully response. So ultimately the DHCP is working. So this is a DHCP configuration. So we explained manual IP assigning process and the DHCP, the dynamic host configuration protocol, how to works. So next we will concentrate on IPv6. So IP version 6 is advanced. Presently we are using, this is maximum 128 bits supports. For 8 classification is there. Each one 16 bits as support. So what all the features are there? First one is a high address space. So 128-bit, this will be supported. So we can create maximum 4 billion IP addresses. So the constraint we can avoid, suppose if you are using IPv4, ultimately some want interventions, some want trouble we will face. Suppose beyond the IP version 6, if you want to broadcast our data, ultimately the additional support we need. In the IPv6, there is no constraint. Directly we can interconnect wherever the destination point, so that the high address space support by the IPv6. Improve the packet handling. Packet handling is very, very easy, and eliminate the need of network address translation protocol. The NAT where we are using, when we are using the IPv4 packets, IPv4 supported machines. So inside the network, there is no problem. Directly we can communicate. So beyond the IPv4 network, suppose our source is IPv4 supported machine, our destination is IPv6 supported machine. What will happen? So the contradiction ultimately we face. So for that, the network address translation protocol helps to convert the IPv4, that this packet encapsulated with the IPv6, IPv4 encapsulate with IPv6 for 6. So the destination, when we reach the IPv6, put to the destination and exit from the destination. So with the help of network address translation only, this is possible. So if you are using IPv6, there is no contradiction. Directly we can send from source to destination wherever the globe. So integrity and security, this is a more secured protocol. So more secured IP, so that even authentication, integration, integrity, security is much more high than the IPv6. 4 billion IPv6 addresses supports presently. Simplified header. Header is very, very simplified header. So later we will discuss what is a header. And large payload. The payload, so the datagram is, we can generate multiple datagram. Large datagram we can generate by the IPv6. Auto config for address. Auto configuration. IPv4 cannot be support IP auto configuration for address, but here this will be one of the advantage. New option, many option is there in the IPv6 because of 128-bit supported. So example, this is a IP. So 8 classification is there in the IPv6. In the IPv4 only 32-bit support. So basis on the classification, the network field and the host field will be present in the IPv6. So it will divided into the 8 part. Each part we can assign a hexadecimal value. So in the IPv4 we support only decimal point, decimal supported. In the IPv6 we can directly use hexadecimal value. So the reason behind the 4 billion IPv6 address. So IPv6, how to optimize IPv6? Suppose we design an IP address. So what are all the things we should remember? Leading 0 within group can be omitted. Suppose if you are writing 16 bits of IPv6 address, we can omit more number of zeros or zeros. So for example, our IP1 bit is 0, 1, 2, 3. We can reduce as 1, 2, 3. We avoid 0. So, and second optimization thing is, one or more groups of bits can be replaced by a pair of colons. Suppose more number of zeros are present in the IPv6 generation of IP, ultimately we can put double colon. So suppose suppose 8000, this will be extended. Here 5 bits are there, so remaining 3 bit may 0, so that we want to write 3 pair of 3 bits consistently. We want to avoid write a 0, so that instead of that we will put as a double colon. this is what is the meaning of the double colon means. So behind this, so 3 bits zeros are consistently inserted. That is the representation behind the double colon. So this is a optimization of IPv4. So this is a very simplified header. In the IPv4 is a more number of contribution is there, but in the IPv6 is a very simplified and sufficient header. The version ultimately focused by the IPv6. Next, traffic. The traffic is focused on the congestion control. So where inside the network, where the traffic is raised, where the feasible places are there, so everything is controlled by the traffic class. This is related with the congestion control mechanisms. So flow label only focused on the flow control mechanism. So where is the feasible path is there, according to that this will be executes. So next very important thing is payload length. So the payload length is a datagram. How many number of datagrams are generated, so that the payload length will be defined. The next header is focused. So header length defined, header length existing of base header, so that the header is focused header length. This is defined length of the datagram. This is next header defined by the header. So hope limit almost when we are already concentrated in the TTL and the IPv4, same like the hope limits. So how many number of hopes are present in the network, that is defined by the hope limit ports. That is how many number of routers are present. So source IP address, this is 128-bit supported source IP supported by IPv6, and always destination IP also 128-bit supported. So 3 types IP address we can configure. One is unicast, the single source IPv6 directly send from source to destination, that is unicast. Next, multicast IPv6 multicast address is used to send a single IPv6 packet to the multiple destination, one source. So unicast 1-to-1, multicast 1-to-many. So 1-to-many we can forward the packets. Next, anycast. So the anycast IPv6 anycast address is any IPv6 unicast address that can be assigned to the multiple devices. So multiple devices, this can be support these 3 categories. We can configure IPv6 address. So in the IPv4, we are facing some want constraint, so that this presentation to give a solution, dual stack method. Why we want to use dual stack method? The router understand the IPv4 to v6. For example, if you are broadcasting, that is, so if our source packet is supported only on IPv4, in the destination packet, that is received end will be IPv6. The contradiction will be ultimately generated because of IPv4 machine cannot understand IPv6 packet. IPv6 machine cannot understand IPv4 packet. The dual stack method ultimately give a solution. So the router understand IPv4 data converted into the IPv6. So next, another one important method is the tunneling method. The tunneling method is source and destination will be IPv6. Your intermediate configuration will be a IPv4. So the IPv6 packet encapsulate with the IPv4 packet. So transfer the packet from source to destination. The destination is received successfully from source packet. So the tunneling converted into IPv6 packet into the IPv4 packet into the IPv6 packet. Even the both end will be IPv6 supported, but intermediate configuration always IPv4. Next, translation. So already we discussed NAT. NAT already we discussed it. Network address translation. IPv4 cannot understand IPv4 header. So both header will be entirely differ. So the translation is must to understand the IPv6 supported machine. So network address translation translated to IPv4 address into the converted into IPv4 to 6. So small comparison about IPv4 to v6. Address size is 32-bit. This contains network address and host address according to classification A, B, C, D, E. IPv6 maximum 128-bit supported. So in the IPv4, it cannot support auto configuration. So auto configuration here not possible. In the IPv6 ultimately supported auto configuration. So in the real-time application cannot be supported in the IPv4, but in the IPv6 it is very convenient to implement the real-time application. Here no security at the network layer. There is no security in the network layer in the IPv4, but IPv6 is a more security and authentication providing compared than IPv4. Throughput and delay is more. Here throughput ultimately very average speed only we can get from the IPv4. IPv6 is totally supported in the hexadecimal value. Ultimately the throughput will be high. There is no conversion need for IPv6, so that the reason behind the throughput. So why subnetting? So there is a very wonderful and important part of the networking area. Why subnetting? So when you are erecting the mass network, so not even the small, even more in, for example, 1 lakh machines I want to interconnect with the single channel. So what will happen? Ultimately, we are facing somewhat the constraint. Particularly the traffic will be arise, somewhat the contradiction is there, many more implications arising. So that the subnetting is a very important. So if suppose I want to travel from source to destination, so 1 lakh machine means all the machines are forwarding the packets. So what will happen? So the queue will be increased. So the reliability will be reduced. So that is one of the important role for subnetting. Another one is security constraint is much more. So for avoiding security constraint, ultimately we focused on the subnetting. Another one is traffic. So if we configure subnetting, we are using, ultimately we avoid the traffic. So that is the reliability, more reliable we can get from the subnetting. So for that we are concentrating on the subnetting. So how to find a network address? Suppose we have IP address. So how to find our network address? Simplest one you will take. So in the IPv4 we have 4 parts, each one 8 bits. Totally this is 32-bit length, 32-bit supported IP address. So that 192.168.1.200, this is an IP address. So this is converted into the binary. Try to convert the decimal value converted into the binary value. And what is your subnet? Your subnet is, this is a classification C IP. So 255.255.0, this is a subnet mask. So try to convert this subnet mask into the binary. So already we have converted binary data. Each block of 8-bit converted into the positional notation, basis on the positional notation. For example, this is a 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. According to that, we will try to convert this decimal value into the binary value. Same like the subnets. We will try to convert all the ones that is supported 2 power 0 plus 2 power 1 plus 2 power 2 plus 2 power 3 plus 2 power 4 plus 2 power 5 plus 2 power 6 plus 2 power 7. Ultimately, we will get 255. So basis on this positional notation, we have converted into the binary. This is a very simplest method. So we will try to do bitwise, and if we are doing bitwise and we will be get a network address. So in the bitwise and 0 0 always 0, 0 0 always 0, 0 0 0. So 1 1 only 1. The remaining portion all will be 0. 1 1 answer bitwise and 1 1 answer is 1. 1 1 answer 1. 0 1 0 0 1 0 0 1 0. All the 8 remaining 6 bit here 6-bit present. This is a 0. Here also 1 1 0 combination always 0. Same like that we will try to apply all the 4 8-bit portion. So ultimately we will be get your network address. 192.168.1.0 is your address, network address according to your 192.168.1.200 IP. Right, next. So how to find subnet? So already we discussed how to find the network IP. So this is a subnet, one of the interesting and a very useful one. This is IP address. So 192.168.10.0 is your IP, and 26 is a prefix length is focused on your subnet mask. So that is network portion. So this is your input. This is your question, how to find your subnet. For the IP, we will convert the subnet. Not only subnet, all the things. So this is what type of address. First, you should find what type of address this. So this is a class C type of useful address. Sorry, class C type network. This area 192 to 223 range ultimately support class C. So 3 network ID, that is 24-bit network ID and 8-bit host ID. So this is a class C type network. So next we should write our subnet mask. So our subnet mask 255.255.255. What is the meaning? 255 is a 8-bit. The next 2-bit is a 8-bit. So next 2-bit is a 8-bit. So the 8-bit start 1, 2, 3 up to 24. So the network ID is a 24-bit. So ultimately from 1 to 24 contains a 255.255.255. So what is the remaining? So 1 1. Why we should write here as 1 1? So you see what is the prefix length? The prefix length is 26. Here 8-bit plus 8-bit plus 8-bit, totally 24-bit. This is a 25th bit. This is a 26th bit. So here we have given 26. Prefix length is 26. So ultimately we write as 1. The 1 is represented as network address. The 0 is represented as host address. So that the 1 255, this one and this one 25th and 26th bit position is focused on network bit position. The remaining all the things are focused only on host address according to the prefix length. So I hope this is you understand. Next we should find network. So from the IP we should find total number of network. The formula is 2 power n, simply 2 power n. So what is it? What is the n value? How to find the n value? So the n value is 1 and 2. Double 1 are present here, so that the network portion 1 is represented as a network portion. Ultimately the network is always 2. So 2 power 2 is 4. So total number of network is 4. Next we should concentrate on how many number of host. How to find total number of host? The formula is, sorry, this is a 2 power n, not 2n. 2 power n minus 2. This is a formula to find total number of host. So 2 power 0. So the 1 is represented as network. So we take here as 2. So, but we calculate here host address, so that how many number of zeros are present? 1, 2, 3, 4, 5, 6. So 6 zeros are present here. So that 2 power 6, that is 2 power n minus 2. 2 power 6 minus 2. 2 power 6 is 64 minus 2. 62 is a total number of hosts. So in this IP contains 62 hosts. So how we should find the subnet mask? So from the two, we can easily derive subnet mask. So 192 here, you see here 192.168.10 up to this network area. This cannot be changed. This 0 portion according to prefix length only it will be changed. That is a subnet mask. What is mean by masking? The extracting IP address, that is a masking. So here, so this bit position, that is host bit position only must be changed. How to find? So what is the bit position? That is host bit position is 2 power 6. So ultimately 2 power 6 is 64. So 256 minus 64 is 192. So that is a subnet. So we can easily identify our subnet from the host. So I think I will repeat you. So subnet already 192.168.10. This is a network ID. Why? Because of this is a classification C. The 192, how it came here. So first you see what is our host. So host is 64, 2 power n. Our total network was 8-bit, total 32-bit range will be 256. So ultimately 256 minus 64, that will be 192. This 192 is our subnet. So finally we write 192.168.10.192. This is our subnet. So next, how many number of blocks? So this IP contains 64 blocks are there. So 256 minus 192. So 256 is a total number of 32-bit length. So minus how many number of your subnet host ID? Host ID is 192. So that 256 minus 192 is always 64. So 64 block it will be support. This is a subnetting calculation method. So we find the 64 already. We find the 64. The blocks are, I return the blocks 192.168.10. Up to this cannot be changed. From 0 to 192, how many number of blocks are? That is already we have calculated. So first, this is a network address. How to find network address already we have discussed. So the first address always, all the subnetting address, the first address must be a network address. This cannot be changed. So this is a network address. From the next address of the network ID, that will be a usable address. The host ID we call as usable address. So the usable address we fix in the system. So 192.168.10.1 from 1 to 62. That is a usable address. How we should define here? You focus your block 192.168.10.0. This is your block. The first address always network address. Not only this, even any kind of address you focused in the subnetting, the first address always subnetting, network address. The last address of the subnetting is always broadcasting address. So the intermediate address we call as usable address. So 0 to 64. First subnetting starts from 0 to 64. So ultimately, the network address 192.168.10.0, the usable address 192.168.10.1 to 62. So the 64 address is starts next subnet. So that the first subnet broadcast ID is 63. So why these 63 where came? First you understand. So this is 0 to 64 is our first subnet block. So from 0 to 63, is our first subnet. 0 is the network ID. 63 is the last ID of the first subnet. So the broadcast ID is a 63. So the remaining always usable ID. So next block is 64 to 127. So 64 is a network address, 127 up to 127, which is the deadline of the, that is a destination of the subnetting. That is a, we call broadcast address. So 127 is the broadcasting address. So the intermediate address we write here, this is a usable address. Same like that, 128 is a third subnet. So the 128 is a network address. So 191 up to 191, 128 to 191 is our block. So 128 is a next block. So 191 is a destination, that is broadcast ID. 129 to 190 is our usable ID. Same like that we will configure. So next I take another one example. This is a classification P type. According to classification B, 16-bit must be a network address, 16-bit must be a host address. So that we write here 255.255. This is a network address. So the remaining bit is always here you see the prefix length is 30. So 30 means this is a 8-bit, this is a 8-bit. So 16. This is a 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Up to 30 is a network portion. The prefix lengths define the network area. So the remaining 2-bit, the last 8-bit, 6-bit position, 6-bit position supports network. The last 2-bit position is host. So that according to our formula, total number of network 2 power n is 14 1R presence. So that 2 power 14. So 16,384 is our total number of network. We can find from how many number of ones are present in the subnet mask. So next we should find our host. 2 power n minus 2 is a formula for the host identification. So 2 power, how many number of zeros are present here? 2 zeros are present. Ultimately 2 power 2 minus 2. 4 minus 2 is a 2. 2 hosts are present in the in these B classification supported IP. So next we should find subnet mask. So 255.255.255.252, that is 252. Already how many number of hosts are present to 2, so that we less from the total length. So next we find block size 256 minus supporting host ID. So 252. So 4 blocks are present in the IP. So this is a classification up to 0 to 256 we can classify because of each network subnet supports 0 to 4. So 150.150.0.0. This is a first block address. So we know about first block always network address, the last block always broadcast address. So 0 to 4, 0 first network ID and 3 is a broadcast ID. The remaining portion always 1 to 2 is a usable address. These block always support usable address. Same like that 4 to next IP is 4. Next block starts from 4. So that this is a network ID 7. 7 is a broadcast ID. The remaining thing is a usable address. So same like that we should find from 0 to 256. So this is a block that is a classification B type of subnetting method. So very easy and simplest method. So sometimes this type of subnetting may be complicated. Some people may feel as a complicated one. So this is one of the shortcut method, magic number method. Very easily we can find from this type of method. 172.16.0.129, the prefix length is 26. So we can easily find, just you focus only on the last bit. So what is the last bit position? Prefix length 20 bit means, so first 8 bit are already supported in the network portion. So the last bit, last 8 bit only we should concentrate. That is, this is a positional notation 2 power 7. This is the red color one is positional notation 2 power 6. So why we should concentrate this? So the prefix length is 26. According to this, we should write. This is a positional notation 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6. What is the value of 2 power 6? 64 is the value of 2 power 6 positional notation. So from this, we can easily find anything. So we can write the block. So 172.16.0 to 0 to 0. So already we find 64 is our magic number. So from the magic number, our block start from 0 to 64, one block, 64 to 120, the next block, 128 to 192, the another block. So we can find easily. Why we stop here up to 192? Because of our prefix length is 126. So up to 192 only we can concentrate here. So from this we can find easily which is the intermediate address from 192 0 to 192. So suppose 192.16.0.127, this is a first usable address. Here we asked one question, which is the first address of the 129 host between 128. We can easily find, suppose the intermediate address, first address, second address, third address, which is a network address, whatever may be the question, we can easily find from the magic number method, very simplest method. So according to prefix length, we try to concentrate on define the magic number. So basis on the positional notation. So another one subnet method is there, that is VLSM. So this is a very simple method. VLSM method, variable length subnet mask method. Suppose you desire to configure one biggest network. For that, we should plan your IP, how to define IP. So ultimately, the VLSM is a very simplest one. So you will take, this is a local, consider as a local area 1. This support 100 host. This is support 100 host. So we calculate 100 host. We calculate IP to 100 host. So required number is 100. We will take, you assume required number is 100. So you should find nearest maximum from 100. How to find, you know, prefix, you know, the 2 power 0, 2 power 1, what is the positional notation? According to positional notation, we can easily find which is your nearest maximum. That is very important, nearest maximum. So 128 is a nearest maximum for the 100. So we choose 128 is our host, right? This is assumption only. So required number is 100. First, we should assume which is your nearest maximum from your given data. So I want to assign IP to 100 machines. So ultimately, 128 is our nearest maximum from the 100. So the host is 2 power 7. Positional notation basis 2 power 7 is a 128. So the formula is network is host minus network. So our host is 32-bit. Our host always 32-bit because of this is IP version 4 type of IP. So that the 32-bit we will take for host. So minus, we know about the network 2 power 7. Why? Because of the nearest maximum from 100 to nearest maximum is 128. So that 2 power 7 is our positional notation is our right place, right one. So 7 is our network ID. So 32 minus 7, 25 is our network. So from the 25, we can write our subnet mask 255.255.255.128. So these 128, according to positional notation, so the 25 where it will be placed. 225 is 128-bit magic position. So that we have written 128 bar 25 is a network portion. So that we have written as a prefix. So this is a subnet mask. So from the approximate number of machines, we have easily calculate the subnet mask using variable length. So next we have taken 40. For this 20 host, we will try to configure subnet. So host is, which is your nearest minimum for 40. Nearest minimum from 100, this is not this is wrong, only 40. So 40 means 2 power 6. 64 is our maximum nearest for 40. So according to formula, network equal to host minus network. 32 bit is a total length of IP. So that 32 minus 6 is a network portion. That is 6 is a network portion. So 32 minus 6 is a 26 our network area. So if we exactly calculated, network is 26, so that we can easily define our subnet mask 255.255.255.122 according to magic number. The 26th bit position is 192. So that we can easily, that is 126 bit position is 64. 64 plus 120 is how many number of ones are present. Basis on that we added, so that the 192 are present here. The 26 is a network portion, so that we added as a prefix length. So next we will calculate for 20. Same like that. So the required number is 20. For this we will try to find our subnet host is 2 power 0, 2 power 5. That is our nearest minimum from 20. That is 2 power 5. So that is answer is 32. According to formula, network is equal to host minus network. 32 minus 5 is 27. So basis on this, we consider as a magic number. So 28th bit position, that is up to 24 only 2 consistent 3 bits covered. So the last 8 bit starts from 25 plus 26. 25 bit position is 2 power 7 plus 26 bit position is 2 power 6 plus 27 bit position is 2 power 5. So we added all the 3 consistent number of ones. So 224 is our and host ID. So that we derive our subnet mask from the host ID. So the network number is 27. So added this area as a prefix length. So next we should find 10 host. For 10 host, we should find our subnet mask. So which is the maximum minimum, which is the maximum nearest from the 10. Ultimately 16 is our maximum. 2 power 4. 16 is our maximum nearest from the 10. So ultimately we substitute in this value to the formula. 32 minus 4 is equal to 28. Subnet mask is 255.255.255. So where we know how present 28. So 28 is always 2 power 7 plus 2 power 6 plus 2 power 5 plus 2 power 4, ultimately 240. So this is a host number. The prefix length we have added from the network. So this is a subnetting concepts. So so we discussed subnetting, the subnetting, normal subnetting and variable length subnetting and magic number method. So already we have discussed. So discussed with the example of various classifications. So next we will try to configure one network from the subnetting. So previously, we interconnect two LANs without router. So this time we will try to assign one router. So two LANs we can interconnect via router. So one important thing is that when you are going to configure router, the router interface must be gigabit Ethernet, because of router is most advanced than the switch. So if you configure fast Ethernet, we face somewhat constraints, so that we will try to configure over the gigabit Ethernet cable. That is very, very important. Gigabit Ethernet 0 by 0 by 1. So gigabit Ethernet 0 by 0 by 1. Here gigabit Ethernet 0 by 0, 0 by 0 by 0. This is interconnected for fast Ethernet, no issue. You assign IP to all the machines. So 192.168.1.2. This is your IP. Here we want to give a default gateway. That is very important because of we interconnected router, so that the default gateway is very important, where the packet cross, which is your right medium to travel from one LAN to another LAN. So that is very important. We must configure our default gateway 192.168.1.1. This is your default gateway. So you assigned IP. So next, this is this machine 3. If you press tab, ultimately subnet mask will take by packet tracer. The default gateway is 192.168.1.1. So we must give and close it, same like the process. This is a 4, 2, 3, 4. Next subnet ultimately taken by the system. Default gateway is 1. This is 5. 1. So local area network left side is over. Next, try to give right side. So the left side we have given one set of IP. The right side we will try to give another set of IP. So 172.16.1.2. One 72.16.1.1. So this is another set of IP. So the left side local LAN already we assigned IP, and also right side we successfully assigned IP. Next you configure router. So go to config area, go to interface, and before that check your interfaces. So this is a left side 0 by 0. So 0 by 0. Here you should give your IP 192. What gateway you have given to the left side network. So you should hear for the router address 192.168.1.1 is a gateway, so that you should give IP. The subnet mask dynamically taken by the packet tracer, and very important role you should on your router. So suppose if you off, this cannot be executed. So remember it, you must be on your router and close it. So go to 0 by 1. This 0 by 1 interface, this 0 by 1 interface, this is a 0 by 1 interface. So what IP, what a gateway you have given? The gateway 172.16.1.1 given here, so that you give IP address to the router and enable your router, close it. Next, try to ping it. 1.2 is a left side network address. So this is pinging. This connection is successfully done. So next you will try to right side 172.16.1.3. So we'll check what is our problem triggered here. This is pinging. So left side successfully done, right side successfully done, and where it is the problem. Yeah, it's working. So we ping from left to right and right to left. Already we right side network pinging with the 192.168.1.22. It is working. So with the help of router, we can interconnect two different subnetting supported networks interconnect with the single channel. So this is a subnet example hands-on. So up to this, I hope you all understand. If any queries, please ask me. Question. Okay. Dear participants, if you any queries, please put your queries on your chat window. Subnetting, why we want to configure subnetting in the sense, if suppose mass network, if you configure as a single type of IP, many contradiction we can face. Security issues we may face, and traffic problem we may face. For that, we are migrate from normal functioning, from normal IP usage to the subnetting. The subnetting, it is classified into the single IP, can classified into the multiple, extracting the things so that we can easily interconnect the machine, and traffic free signal we can receive and broadcast, and security free, reliable and convenient transaction we can achieve, so that we focus on the subnetting thing. Our IP has subdivided into the similar part, that is subnetting. So with the help of subnetting, we can simplify our network. Yogesh clearly asked dynamic sharing in the sense, what you are expecting, please. Dynamic sharing in the sense you are representing as dynamic IP assigning or some other thing. Please trigger your question is correct manner. Are you expecting DHCP or other than DHCP? Please. Prakata, IP address, why media independent? The IP address only covered, that is in particularly IPv4 only covered inside the network. So beyond the limit, we can somewhat conversion we want to use. Otherwise, we cannot achieve reliability. So that we are using somewhat tunneling method and NAT. So like that concept, we are using broadcast reliability. For the purpose of broadcast reliability, we are using. So that this is a media independent. Any other question, please? Uses of IP address means without we all are have someone address for the communication purpose. We want to use. That is a main thing. So each and every one of you have your unique address, communication address. So the same like that, the IP address also, the system must be keep on unique address. So any other question, please trigger. Where use of NAT? Veeramani, the NAT is network address translation protocol, which is converted into IPv4 frame format into the IPv6. IPv6 not able to transfer beyond the limit geographical region, so that we are ultimately using for the conversion of IP destination, we are using network address translation protocol. Any other question, please? IPv6, Yogesh, yes. IPv4 is a limited amount of IP address generated. But presently, we are using mass communication. Right now, in the IoT, social media, everything and all, we need a much more mass IP addresses we need, so that in the year of 90s, we erected IP version 6. This is a more reliable, more secured, and almost 6 billions of IP addresses generated by IPv6. So that is the most advantageous compared to than IPv4. That is 128-bit maximum length supported. So that the reason. Any other questions, please? One Priya Krishnan, this is a single certificate to the 6 days. Any other question technically, please? Veeramani, how to change, your question is how to change a static IP address. So if you are sending our data to the destination, encapsulate our information, that is header part is added with source address and destination address, one as a error identification address. So for the purpose of destination address finding, we have used it. This will be first from source to directly interact with your router, then router to destination, it will be forwarded. Any other questions? Yes, it is possible. Pragati, it is possible to convert IPv4 to V6. Already we have discussed it. NAT is supported to that. network address translation protocol convert IPv4 address to the IPv6. Suppose our network is only supported on the IPv4, means we cannot receive and send to the IPv6 supporting any region. So that ultimately we are using network address translation protocol. This protocol beyond the IPv4 supported region, this will be converted the original frame format into the IPv6 format. This will be converted to the IPv6 format. And not only IPv4, the NAT and the tunneling method also we are using. Yes, Maladi M, yes, under research, IPv6 presently we are using. So beyond the limit we need, because of presently we are in IoT and data science technology, mass of network IP addresses we need. So presently we are using IP addresses. Under this research, many things is there. Our Pragati, the tunneling is both side, and sender side and receiver side, both side entirely differ IP address we are using. In between, the IPv6 encapsulate the IPv4 address and destination, reach the destination, then exit from the destination. That is the role of IPv6 when we are using the tunneling method. Any other questions, please? UKS, yes, yeah, you know, you can access other network address if you are going to concentrate on ethical hacking. If you finish, definitely it is do it, but that is an unethical manner. As an IT professional, we avoid like that. Pragata, where we use a tunneling method. Presently, one simple LAN or WAN, it is okay. When you're going to configure on the internet, ultimately, we connected with the global world. So the IPv6 is very, very important. That moment, the tunneling will be, we should use. I will share the PPT. Any other questions, please? Thank you, my dear respected professors and my dear students. Thank you very much. I hope you all understand this session. Tomorrow, I will explain in the depth manner with the packet tracer with packet tracer 7. Thank you very much. Thank you one and all. And I express my sincere thanks to respected my principal, vice principal ma'am, and head of the HOD in charge and other faculty members and coordinator of the 6 days sessions. I thank you all. Thank you very much.
Thank you, sir. Thank you for your valuable presentation. Participants, hope you all get a clear idea about IP addressing and subnetting. Tomorrow, we have a hands-on session on using packet tracer. If possible, you can install the packet tracer. If not, you may kindly refer the video for your future reference. Now, the attendance link is shared in a WhatsApp group. Kindly fill the form within 15 minutes.